How's it going, everybody? Happy Tuesday. Coming on to some holidays here. That should be nice. Of which I'm gonna have some time off, and I'm hoping to do a bunch of video content. See if I actually I feel like I've said that a few times. It's not always easy to establish new habits or make time and prioritize things, but we try to be here every Tuesday. So what we're looking at today, in the past few streams we have done a little bit lower level type exploration. There was a RFC with POC, lots of acronyms there, a request for comments that included a proof of concept, which allowed one to have a render a web view with a raw window handle, which meant that we weren't necessarily the integration between the actual window and the web view itself wasn't nearly as one-to-one or tight as it had been. We have a little bit more flexibility where we can like mix and match and draw a Bevy app and a web view in the same like container space, basically, which I think is gonna be really interesting. And I haven't seen any dissent or any reasons to not to move forward with that. So TBD on like timelines on when that actually lands. But when it lands, there's other things we need to think about when we would work with that type of model, like the data moving between the WebView layer and a Bevy app, for instance. Presuming we're drawing both of those, there's some assumption to be had that we want to share data between them. And I thought it would make sense to start that conversation. Data management and like moving data between these different types of contexts by digging into how the current like data from WebView to Rust backend currently works, and what we've been looking at as alternatives, and like digging into the actual like implementation of it. Because I think I wouldn't describe it as like terribly complex. There is complexity due to the fact that we want to not accidentally open up like security vulnerabilities. I would posit that most of the complexity comes from that, but when you look at the actual code, the implementation isn't nearly as involved as you might expect. So we can kind of like look at this pattern, see where we're going with it, and see how we could also potentially use it in other situations. We'll see. I thought I had a hard stop. We might not actually have a hard stop though, so we'll see what our stretch goal looks like. But I think it's gonna be interesting. Hey, good to see you. Good to see you. Lost my chat window. There we go. Cool. How's it going? So where do we start? There's a couple like built-in kind of communication protocols or patterns, maybe would be a better way to say it. And then there's kind of these like alternative, you have to set up a little bit more on your end to get it working type situations, but there's trade-offs in all of it. I think where we start though is, let's go over to our display here. We don't really need our terminal at the moment. If we look at the guides on the main site right now, there is somewhere in here I was like just looking at this yesterday. Let's see. So there is a let's see if we might be able to search for it. Yeah, isolation pattern. References. That makes sense. This used to be on the other page. So if we look at the main inter-process communication explanation, we have a few. So IPC stands for inter-process communication. And effectively we have these isolated processes that are trying to communicate. There is a particular style called asynchronous message passing. Yeah, and this is kind of why it's not really the situation, but I'm comfortable describing it as WebView is kind of your front end, Rust is kind of your back end. It's not exactly the same, but it kind of is. And this is the bit where I was mentioning where we start to get into security situations where you do shared memory, direct function access. Now you start, yeah. So like here we can, if the message is seemingly malicious, we have the option to like discard it. So there's a little bit more of a separation there, and the web view is a little bit more sandboxed. None of it's gonna be perfect. You can always like work yourself around and remove security features. But when you're actually designing and setting this up, a lot of the complexity comes from, let's set it up in a way where we don't allow somebody to accidentally remove the security features without their explicit intent. And then also just like not leave any holes open for like backdoor type situation. So we have events and commands are kind of the main two ways that we do this communicate, and then we've got these patterns too, which we'll come into, because that's going to end up showing up in the code that we look at. We can fire off events, which are IPC messages, when, and this is one of the important bits, events can be fired off by both the front end and like the core Rust side of things. In GitHub, we made a multi-window app on stream, and this does it opens up windows and it does most of the like communication. There's not, it's more of a contrived example than it is really like a real, I mean it's kind of a real specific use case, but part of it is just contrived example. But this uses messages to communicate between the separate windows. Set up with React, or actually Preact. if you are familiar. And we've got... There is, I believe, a section where we did like message passing. It's been a minute since I looked at this. Yeah. So most of the effort is happening in window creation. We have a create window. This index.html is the main window that gets rendered. I didn't even change the title. And then let's see, I think we should have another HTML file in here, I believe. Question is, where did I stick that thing? Colors, here we go. This is listening for events. So this is the web view side of things, listening for events over this like IPC layer. Hey Tony, good to see you. Good to see you. So events, front end, back end, we fire them off, and you can think of it very much like any other event system within, like, if you're familiar with the JavaScript side of things. The other option is commands, and that uses the invoke API. Similar in thought process to fetch. And we might come back to this because that's a very interesting piece of this. It uses a JSON RPC like protocol. This is I want to call it a caveat, but serializing does come with a little bit of cost. It, depending on the app, may be completely negligible. We have run into situations though where that starts to become an issue for very like specific apps. I think like video data transfer, where there's a lot going over the wire and it's not really useful to serialize. We start to see this come into play. And this specific situation ends up being one of those cases where it might make sense to use a different protocol to meet your specific need. Hey John, good to see you. Yeah, using the 3D, and it works. It worked. I didn't break it. Counter, whoop, went the wrong way. Counter is working. Chat's working. I also didn't touch anything for over this past week, so I'll take the wins where I can get them. So we kind of had these like two groups. Events, both sides of the coin can use it. Commands are, it is front end invoking Rust functions. And within this like umbrella of IPC, we have two patterns, Brownfield and isolation. You see Brownfield is the default, which likely means that if you've made a Tauri app, you've probably used this. Can we collapse this sidebar? That would be nice. There we go. There we go. I don't think that's right, stream elements. I don't know that I've actually paid attention to that. I think I set that up a while ago and then just forgot about it, to be honest. That might still be left over from Twitch. Actually, no. I think the stream elements, YouTube and Twitch, are pretty disparate. Either way, the intent is that this down there starts to become the like, this is how you do commands. And then the counter is the like, commands are cool, you should try them because other people are peer pressure type thing. So those should work. There's a couple more that I don't think I actually have. I think I have some more, but I don't actually have them down there. Well, I mean, clearly Stream Elements is hooked up. I think it is working with some of the YouTube events. But YouTube is a little bit different than Twitch in that there's more privacy, there's more expectation of privacy baked into YouTube. So you have to like opt into making these events public for others to see. And those would be the only events that I end up seeing like from a like Stream Elements overlay type situation. But most of the command stuff, I mean, here we're a little bit, we're digressing, so I might as well just jump in. I'm using this. So most of my command handling and whatnot is working based off of this with the overlay that I have in place. So I still have Stream Elements technically set up to handle some of the alerts, but we just don't see them because of privacy things. Okay, so we've got these two patterns. We've got Brownfield and that sidebar was helpful. Okay, I guess I'm going back to I like the sidebar, but I don't like the sidebar. I think we've adjusted this once we are in the next version of the docs. Okay. That's an interesting question for our current topic, because when we're discussing, I feel like you can kind of bucket these things in two situations. When we're discussing WebView communicating with the Tauri Rust backend, it's anything wired up directly with Rust and like happening over either an event or a command. So an event or a command triggers a thing. That doesn't necessarily mean it has to be a Rust thing that's executing, because the way Rust is set up, Tony, we were talking about this yesterday. Rust can invoke other processes and other things, and there's a way to bind these pieces together. So you could theoretically have a Rust thing executing C, C#, whatever thing, and that could happen like triggered from the front end, running a command on the Rust side of the thing, and then Rust taking over and doing its thing. What's interesting about melee search is it's Rust. I haven't actually looked into it deep enough that I would know if it's possible or not. But melee search is sort of set up with the expectation that it's running a server. And it's this like ongoing running process that accepts basically like read and write requests. The write request is more of a like, here's some metadata, go update the thing type of write, rather than like put this value into the database. So I would almost say that melee search, I mean, if you're thinking very like local first app, where you want a like local first database and it's only gonna be running when you're sitting at your computer using the app, you could potentially run melee search as a sidecar. And that would be, I guess, the other type of what do they say? Communicate secure. No, they don't have the thing I was expecting to read. But basically, we're communicating between processes. So when we have a sidecar, we're bringing along an additional binary or something that Tauri can start up and execute and run as like a child process. And then you still need to communicate with that that doesn't happen over IPC unless you set up like a command specifically to handle that. So that would be like a different protocol or a different way that you would actually access or trigger things running in that like separate sidecar binary. But it's still technically like inter-process communication. It's just not this. So there, do we have a guide on that? I think we got a guide on that. Embedding external binaries. We call this binary as sidecar. I'm not saying that melee search couldn't be directly incorporated, but from what I've seen, they have designed things to the way, or they've designed things in a way that the expectation isn't necessarily there. So if you could get it working, I don't know that it would be very easy to guarantee that it would continue working that way. Like as melee search updates. So I suspect that this pattern might work better for that situation, depending on what you're doing. Does that make sense? So we have inter-process communication, but there's a little bit more of like a tighter integration between the actual like Rust backend that's starting your Tauri app and the web view contained within the window. But if melee search was set up in a way where it wasn't expecting to be run as a separate process, there is a possibility that you can more directly incorporate that into your Tauri Rust backend and have your front end via commands or whatnot invoke the functions that melee search is expecting you to. And we might take a peek at something that sort of fits that categorization, I guess. Okay, so inter-process communication. We've got the Brownfield and the isolation. Brownfield, I suspect most people are using because it's the default. It's just that's default things. The I'll actually just move this over a little bit. Yeah, there we go. So maybe let's check out this first. The incompatibilities. If the API is not widely supported across browsers, it probably won't be supported across all platforms. So depending on what like pattern you use, you're going to have situations that you might have to deal with or haven't been established in Tauri to actually deal with them yet. WebRTC in Linux is just one of those things that have been painful to set up because there's the pros and cons of Linux is everybody can have their own opinion and set up their own flavor of Linux. That doesn't make it easy to like support features. So Brown, I guess we just go back to here. I guess I basically just point to Wikipedia for the definition. This is definitely the my background is a little bit more of that. So whenever I hear Brownfield, that's definitely what I'm thinking of. Do we have an explanation? If they in short, it tries to require nothing additional to what is existing on the web front end. It's really not a great explanation here. Those links don't show up on our side. Which links? Which links? I'm not sure which links you're talking about. Oh, are you? Wait. Never mind. Okay. All right. I was like, I'm not seeing what you're putting down, Tony. Doesn't mean certainly apt to miss things. So I think we'll dig in and look at Brownfield. I mean, this is sort of just a generic term, you know, like legacy software. They were there before I came in. Oh, okay, yeah. Can you see chat history? Are you able to scroll? Oh, like these? There we go. Can you see the chat history in YouTube? So I actually click on that. The other option is isolation pattern, and I would actually be curious, like, how many people are using this. Can't see chat history. Interesting. I'm pretty sure, like, as a default, you can. I don't think I've, like, turned on anything that prevents it. So isolation pattern is the other option, and I would definitely be curious to see who's using this. And I think the biggest issue is like inconsistencies, because it is working within the context of an iframe. An iframe ensuring more sandboxing, which is good, but also like writing your code to be run in an iframe, if you've ever worked with iframes, is not a fun time. Yeah, newer mechanisms such as ES modules don't load. So I don't know that we're gonna like dig into this too much. I think the important bit to note is that it's we're working with iframes to help ensure the security of it. Encryption of the message occurs. There's overhead costs, and then it's encrypting, decrypting the IPC messages. Testing is gonna just not be fun, and this the iframe thing. I think those are the big reasons, and there's a big push, especially more recently, towards the ES modules. So unless the iframe situation comes along further, I think this is going to have a very specific use case, or very like a niche set of use cases. Just because the reason you're using Tauri is because you can write code that's expected to be run on the web. But if you can't actually use it, and you can only use a very small subset, I feel like a lot of that benefit starts to go away. So what we'll see some isolation code, and we might look at it, but we're specifically focusing on is the Brownfield pattern and that communication between the like Rust backend. So let's go over to, we might generate a project to take a look at and see if we can, whoop, that's not what I meant. I meant GitHub. We might generate a project to take a look at. But I think we're going to start by looking at the code here. And if you have worked with Tauri and put in the API package, this is what we're looking at here. What would be a good I feel like I've used window a few times. You can affect the window by doing things. 8-ball? Is that just a default stream elements one? I don't know if I even have that turned on. Tony over here like pen testing my setup. I mean, I've got all this set up to do commands. I just need a little bit of time and space to actually do it. Like I've got a whole bunch of commands like set up. I think some of these are all still wired up to Twitch, and I just haven't updated them. I've got ideas and things to do, especially if you've watched over on Twitch. Shout out to Finite Singularity. They have been doing a lot of shader work in OBS, and I know you have at least a passing interest in that, Tony. They've been writing a handful of OBS plugins on stream, writing the actual like shader code that allow you to like do filters and whatnot. So if you see like when I point, it's a little bit subtle. But I mean, you can see it if I like put my hand together. There's a, what's the word I'm looking for? It's like an edge. It's got like edge detection type of thing. That's a plugin from Finite Singularity. But they have a whole bunch of other filters, and I kind of want to make some fancy commands and cool things with it, but I just haven't had the time. Maybe soon. I have a little bit of vacation coming up. I might burn some cycles on that. Okay, so window is doing. This has got a little bit more to it. Nice tabs only. Yeah. But I mean, like, I mean. You haven't done that one yet, Tony. Whoa, pointing. All in the corner there. You've done one of those, you haven't done the other one. Try to break that. This has got a little bit more going on. All of these though. Here, we'll stop on what's a good one to stop on? These are all ises. It's not terribly fun. Yeah, I guess. All of these return invoke, and it's got like a string, which is almost in the vein of like a router. Yeah, so that drop, we did all of those models on stream in Blender and pulled it into React 3 fiber scene. And you can do like drop stars. There's some filtering that works. It's fuzzy-ish, but not super. It's fun though. And the that is in the same context. So if you happen to do a drop right when I do a highlight, it'll all bounce off of each other. It's little things that make fun. You feel like you're always trolling. I mean, there's a reason I put it in. If I didn't expect people to come in and poke around, I wouldn't put it in. And I mean, we do a lot of that, just like not the trolling bit, but the like poking around. Like I feel like learning by experimenting is very much speaks to how I like to learn. And I feel like we do a lot of that on stream. So if you'd notice, all of these end up ending in functions that are just doing an invoke, passing some data, and using a string. That string is, the invoke comes from primitives. So if we look in a bunch of these others, it's going to be the same situation. All of these end up just calling invoke. So what we're doing in this package for the most part is kind of just mapping. And if we look at the primitives and we go to invoke, when you create a web view within Tauri, there's a couple of things that are added to the window object in the web view. There is a I was looking for the docs. Yes, here. If you enable build.with global Tauri, it puts it on the window underscore Tauri parameter, whichever. It shows up there. Otherwise, it's in this like internal one. So it's, I think technically you can still access it from there, from the internal one, but it's sort of like a way to have a private versus public API as best as you can within the JavaScript ecosystem. But what we're doing is we're just calling this window Tauri internals. So how does that get wired up? Within the main Tauri repo, we kind of have two pieces. If you look at the languages, for the most part, it's Rust. We have a couple other things, like we're starting to pull in Kotlin because Android for mobile. And you can see that the TypeScript is pretty small because for the most part, we're just writing the mapping code at this point here. And I think there's work to actually just generate some of that mapping instead of having these hand-rolled libraries that do this. So we were looking at Tauri tooling API. I think, bundler and CLI are all Rust now. And core, most of this is going to be Rust, but there is I think it's core. Is it core Tauri? There is a little bit of JavaScript still in here, and I need to remind myself where it is now. This is, nope. So we can see the isolation pattern showing up. So there's a little bit extra code, and we can see, remember we were saying that it does some encrypting, decrypting type things and iframe type things. You can see those showing up on the right side of things. And then the isolation is doing a post message and crypto things. So here we go with our encoding. And we're effectively doing like this message passing. And you can see again, we've got another piece of like Tauri internal stuff that's on the window object. All right, where's the JavaScript? Bench, bundler, CLI. Thought it was in core. Config, macros, runtime, fry. Here, scripts, Tauri scripts. So the core, for the most part, includes Rust. And we can see some things like, here's the patterns. And we can see here's Brownfield and isolation showing up. So we'll probably get into this part of the core once we move from how's the JavaScript side of things hitting Rust. And we can see some bits in IPC might be where we would also want to look. But if we look in Tauri, core Tauri scripts, we have the IPC.js. There's some isolation stuff. But you can see here that we've got defined property IPC. And where's the mapping? There should be a mapping from invoke to IPC. So Brownfield here, it's doing a post message. Post message, IPC. Core, I think it's core. Here, invoke. So when we're pulling that API package and calling invoke, we end up basically ending up at this function, which is already imported into the web view. It is then calling window.tauri internals IPC, and IPC is what we were just looking at. Here. So it then, again, Brownfield is the default. So when we are importing the Tauri API package in JavaScript, it's hitting the window object, looking and using Tauri internals, calling the IPC function, which eventually ends up here. And that then ends up calling the post message to the backend. So this post message, and you can see here iframe, Tauri isolation. And here we can see, it's checking the payload. So these are the bits that its isolation is doing for you. It's checking the payload, making sure it's conforming to whatever, the specific structure of it, and running a bunch of this in the iframe. So those are the security benefits that you get from it, but you're then also having to operate within those specific limitations. So it's a trade-off. But the default is the Brownfield, and this ends up calling the window Tauri internals post message. So now, if we go to the post message, so the downside of using all these pieces on the window object, we don't have imports, which makes it a little bit harder to know offhand of which, where are these pieces coming from. I just clicked in there. IPC. Transform callback, invoke. Alright, where does it is specifically under Tauri internals. What is this? Process IPC message function. Okay, so this is the actual function. Isolation again. Iframe is showing up. It literally creates an iframe. And from that iframe, you get the script sandboxing. Oh wait, okay. Did I miss this before? I don't know. So it ends up calling the Tauri internals post message. So we're now, you import a package, the API package is calling an invoke. That invoke ends up firing a function that's on the window object, which then fires the IPC function, which then fires the post message if you're using Brownfield. And you can see this is on the dev branch, so we're starting to see bits and pieces around Android iOS considerations. But for the most part, what we're doing is we're calling a fetch then. Process IPC. I think we just looked at this. This is the IPC message function itself. So we get a payload, and then we call fetch in that, and it's doing the convert file source command IPC. The Android, we need to split here because on Android the content type gets duplicated. Interesting. Okay. So if there's also custom protocol stuff, and that's what we're getting into there. There's from the message, we've got these variables. Custom protocol is going to be if the flag is set to true. So when the function is fired, if that setting is set to true. Oh, not on Linux and Android. Interesting. The command is the fetch data command. Okay. And not on macOS with an HTTPS URL. So we start to get into custom protocol, which when we fire off like a fetch call, you can or some sort of link. There's the if you've heard of deep linking or like internal linking. So instead of like HTTP:// you can do like other protocols there basically. So you can see location.protocol. I guess I'm. So this is this bit right here. So custom protocol we might want to look at, but I think for the most part, as far as the discussion goes right now, what we care about is doing this process IPC message, and then doing a window IPC post message. And process IPC comes from this, which I think is this. Where is it imported? There's a raw, I believe, right? Okay, so we've got a couple. IPC script, pattern script. And here, depending if you're on Windows or not, or I guess Windows or Android, there's also this protocol bit that we need to deal with. So like, if it's on Windows, the protocol, rather than being the protocol : / you need to have the HTTP in front of it. So things start to get funky. But most of this like invoke stuff is, if we're looking to do like an alternative or an additional integration or what have you, unless you're attempting to do this over a different protocol, you can use this invoke bits directly. So it was calling freeze prototype. Okay. So IPC protocol is doing, it sets up the post message, and then it does window.ipc post message. I think is that just like a, no. It might be. So the window object has, I don't see an IPC. I've never actually like looked at the window object other than what I've needed off of there. So I don't even know if this is this something that Tauri is injecting? Yeah, it's the piece that I'm not 100% certain off of. Because post message is a thing, right? Window post message. But that's just window.post message. So yeah, so like I think this is probably, if you've ever used or seen post message, I suspect that this is the situation. Your app opens up a pop-up and you need to somehow communicate with that pop-up. That's likely using this post message. But between a page and an iframe embedded with it. So in this case, I'm pretty sure it's the same post message, but it's using post message to instead communicate with the Rust backend. So we're not like necessarily reinventing the wheel here. We're using and taking advantage of this like embedded operating system web view sandboxing. I do want to come back to this custom protocol though. Okay, so there should be a where's that yeah, this is all Rust. Mobile. Okay, so we got some Android, some iOS. No, I gotta imagine it's in here. So where's this IPC thing coming from? And it's on the window.ipc. So all of these, well, we might be able to search for it. All of these are doing an object.defined property. Can we search for that? Because if we're defining it somewhere, we should be able to find it then. That's unfortunate. I mean, I guess it gets signed in. It's easier to make sure I don't accidentally leak something if I'm not signed in. Here, I'm gonna just do it on the side real quick here. I don't think it's necessarily an issue if I shared my screen, but just in case. Just in case. So I am going to look within. Oh, way too many repos. Tauri. So we have path, Tauri pattern, post message, IPC. All of them are under Tauri and Turtles though. So if we look at like web view to window object. Or like a list of. Nope. Yeah, that's not gonna help us out here. I mean, like if we look at just the MDN docs under the window object, we don't have IPC. That might be something that's within web views though. But I don't know offhand. I would expect if we're injecting it that it would be in that scripts folder though. Sample apps. This is all gonna be let's start up I can actually use redacted because we've got some messaging happening in there already. Let's start it up and look at the window object. So like if we would just go to our app here, good old React, I can do console.log window. I'm gonna let Rust do its compile thing for a moment while we're looking still at this. So what we end up calling is under post message, we're doing window.ipc post message. So IPC comes from somewhere, and it could very well be that that's embedded within the web view itself. If we're in custom protocol, it's doing a fetch. So this convert file source handles the like custom protocol versus operating system differences. And then after we've fired off that message, we get a response. So if we're specifically talking about a custom protocol or any of these like other special situations, we end up calling fetch, and that's fetch that's built into the browser. Otherwise, we use post message. So I guess I wouldn't be sure. I presume if you're using the default, all the defaults, most of your messaging is going to be post message. Okay, this should be done. Let's go ahead and still got using Remotion to do subtitle stuff. go check out my shorts. I released a bunch of shorts, like snippets from the stream. Hopefully they're interesting. We'll probably keep trying to ship 1 or 2 of those a week, just as another way to, you know, kind of grab the fun bits out of the stream and share it with a larger audience, and something that doesn't require you to sit here for 2 hours watching. Not saying that I don't appreciate anybody stopping by, but this is definitely not for everybody. I understand. Okay, so we've got that. Let's do this and say we are using npm, so we'll do npm run Tauri dev. And I think this is on, pretty sure this is on Tauri 1.0. 1.1. A little bit of compile to do, because I think we've compiled this on this computer before. I don't remember. And what we're going to do is we're going to check out that window object. We can open up the dev tools and check out the window object. And I'm not sure how else we would be able to quickly check what's included with WebView 2. Like, how would we know that that is specifically part of the WebView 2? Okay, so here's our app. A little bit hard to see on. Here we go. That'll work a little bit better. If we look at the dev tools, now we logged out the window object. So the window object is going to have, much like in the browser, if we look at the window object, we're going to have all these methods that are like built into the browser. I don't see an IPC though. Oh, okay. There's more. There's more. Here's the Tauri stuff. Tauri invoke and Tauri. And here you can see, here's the Tauri IPC metadata pattern post message. Do we see just a generic IPC though? That I think would be the question that I'm most interested in. Most interested. I don't see an IPC here. So where's IPC coming from? We might need to stick a pin in it. I'm not seeing anywhere that it would be coming from. There's, like we had mentioned, there's the post message just built in. Window. Is it? Is it like continually nested? I don't know that I've ever noticed that before. Print post message. It's entirely possible that we're still injecting it and it's just not coming in from this little bit. But I'm pretty certain it's just the generic post message, which is we need to handle the protocol stuff, but as long as we handle the protocol stuff, we can post message to like the backend, as long as the backend is listening, I believe. So that's going to be the other bit here. If we now go to the Rust side of things, I believe that's going to show up in pattern. There's isolation and Brownfield. And here again, we have some schema isolation things. I think it's all going to show up in IPC, would be my guess. Mod RS has the IPC request. We have body and headers and IPC response. You can see here's the serialization. I think post message, if we look at the post message here, it is expecting you can dispatch a message event. So target window post message. So I wonder if window.ipc is basically like the target. IPC is the target window, which is effectively the backend. I bet you that's it. It would be nice to find out where that's specifically happening, but I bet you that's it. So I think on message is just a string, which is why we're doing the serialization part of it. This feature is available in WebWorkers, okay. Any basic data type. Ah, okay. So it might not actually be that you need to specifically send. Okay, so there's Saturday JSON. It might not be that you necessarily have to send specifically a string. So it might be like string or object with primitive type data within that object. I guess that tracks. I think I've used invoke with an object before. So I'm specifically looking for the wiring part of it. This up here is the kind of in and out, wiring it up. It's helper function type stuff, and we've got the impls and our structs representing all of that. So there's an invoke message, create a new invoke message from a payload, send to a window. And respond, so IPC respond. And here we've got a async runtime spawn. Reply to the invoke promise with an async task. And this starts to get into the, if you're doing a command, IPC post message triggers that command within Tauri or within the Rust, your Rust like main.rs to run. I think this is like the response portion of that. So if we look at like protocol, again, we're gonna see, I think we opened this up before. Maybe not. We got a message handler, a get. We're doing some HTTP. And we can post back to the message. So if we look now at when we were writing code, greet, and it's doing a format. I was thinking that we did. Maybe we did some command stuff in a separate crate. That might be. So most of our effort here is in we're using the window API. And then we've got a web view window, and we can call like .close. Okay. Let's check out. Guess we can just open it here. We go to the Tauri playground. I feel like we did one of these on stream where we were doing events or something back and forth. Tauri playground. Not the Tray app, is it? So Tauri command. Yeah, no, that's. I mean, basically what's happening here is it's returning, and then that gets sent back via this post message. I thought there was a place though that we were. It's entirely possible that we like didn't commit it or whatever. I thought we had some code examples where we actually set this up and used it. This is trying out Tauri GUI. This might look a little bit familiar. Window.app handle. Open window, create window, so it's creating a separate window. But we're not doing any command stuff in this one either. Maybe we didn't, if we did something on stream, maybe we didn't commit it, or it was in an example. Which is also entirely possible. So if we look at the Tauri apps examples, especially if you're newer to Rust, it seems to be a very common pattern, particularly because Cargo is set up to run these. But it seems to be a very typical pattern to have an examples folder in it. I really appreciate that because it serves as a way, a common way for somebody to write some example code and like just play around with and test their thing. But then it's also kind of works as like a documentation tool, which is really nifty. At some point after reading all the docs, having examples is good and helpful. But depending on where you are with your understanding of the project, it might be faster to just jump straight to examples. Okay, so this is this does multi-window, but doesn't do any like talking between them. File associations. Okay, yeah. So this is like just switching it into the custom protocol stuff, I think. Yeah, your app protocol. So I think it starts to get into that. But back to the examples. I lost my my chat window here. Gonna get some breakfast. Oh yeah, I guess it's still kind of early for you. Thanks for stopping by, Tony. Good to see you. I'm pretty certain one of these does some Okay, so this has got commands. DB lock. What are we pulling in for? Okay, just bug assertions, counter. This is, it's got a connect and disconnect, and it's connecting to the database. And when those commands come through, you can do an insert or read or increment. So if we looked at the script tag here, we've got read, store, increment, counter, which are based off of these document query selectors, invoking events. Oh, no, sorry. I should be more clear there. Based on an event, specifically click events for those elements that it's selected. It's listening for events there, and when those events are seen, like when those events come through, then it runs on a evoke, which is the command-based IPC, not the event-based. So it's a DOM event to invoke, which fires off or triggers the command on the left side. I thought we had I could have sworn we had an example of this, like talking between. Raw future commands. Okay. So, I mean, what I was trying to find was we've got this manager, and the manager comes from app manager. And when you've got, so manager get window allows you based on a label to like grab a handle of that window and then pass events specifically to it. So you can have I don't know if you can go directly window to window. I don't remember offhand if you can, but you can go window to Rust to, like window A to Rust to window B via these events. And that, like the more involved, like abstracted over that setup is in this IPC protocol RS. So we've got handle IPC message. So we're handling some headers. Invoke message. I'm kind of expecting to see like a okay, here's a invoke message or window.onMessage. So effectively we are listening for messages on that window. Create IPC. Okay. We're in the IPC create. Invoke request. So like on the window, we are effectively listening for events. That, I wonder if that means if we're going like communicating from window to window, we need to like have handles to each of those windows. But if we're only operating within the same windows, to like Bevy talking to WebView, I wonder if that's more of a direct thing, if that makes sense, where we're doing a request, and then we need to, on the request, invoke the responder on a specific window that matches where we're trying to send that message to. But if it's all like internal within that same, can we like listen for post messages also on that window? So like, can we have a listener within Bevy and vice versa in the web view? Just listen for messages on that same window. If it's all in the same window, I wonder if that makes the communication between them easier. That would be interesting. We might want to end up digging around with that and seeing what that looks like. Maybe when like this app handle stuff. The raw window handle setup for embedded web view lands in Rye. That might be something we poke around with. So I think this is effectively where this is the gist of it here. We are there's parse and invoke request. It's line 45. We're matching on it. So we have a message handler, handle IPC message. And then we deserialize and check the headers. And then on that invoke message, we format a callback and then invoke the response. So that's like this all in here is where we are on the Rust side setting up to and listening for specific events or command calls from the front end. Format callback. It's going to be mostly like mapping Rusty things into, yeah. And then protocol. Okay, that's what we were just looking at. Channel. What's channel? So channel is just like a message handling. Message handling pattern. So from IPC, channel new ID. This is setting up a channel. So pub function, fetch. Yeah, okay. So I think basically the bulk of the lift is happening like channel and protocol RS. And this is the Rust side of things, the listening and like setting up the window listeners to catch that post message that's sent from the front end or from your front end code. So when an invoke is called, this sets up the message listener, and that message listener gets that post request or that post message and then fires off that command or event that you've configured on the Rust backend. So once we get into that, I think it starts to get into like code gen stuff. There's also event. I suspect event is going to be very similar, except instead of firing off a specific command, yeah, like we've got listeners here. And then is there anything else in here from event listen.js? Okay, so they've got like an embedded embedded listeners, listen.js. So this would be when you're on the Rust side of things. I wonder if it's, I mean, this is setting up a listener in the web view, but it's also wiring up the handler. So I think it's doing a bit of both, because we've got this emit.js. I think so. I would have to look at, I don't remember what our, what's the API for events again? That's what we were trying to find when we were looking at the examples. We have a listen, and then we have, so window specific events. You know, this is where the Rust side of things was subscribing to a specific, like the IPC event channel, or you can have a specific window listen to it. And here, this is the bit that I wonder, if we're firing off events that only the current window can see, does that mean that you could use that as like the channel for Bevy to talk to WebView? So this is specifically creating a new window, but it immediately has a handle to that window. So you can, I'm still not certain, just because we can call an emit here and emit directly to a separate window, I don't know if I think it still travels to the Rust side of things. I don't know that I've specifically answered that question or not. Yeah, and here we got listen. I think I made it on the main. I think this ends up being what it's dumping listeners in the WebView window. So we got listeners and event. Yeah, so I that might actually be where the IPC is coming from too. If we take a look back at, just left open, I don't see it. This is the dev tools. I still have our app running in the background here. So if we look at this again, two are hidden. Okay. This does do some like the prototype stuff is, we can see methods and such in here, but it doesn't always have everything, and I haven't cared enough to dig into what's the specific like I just don't use the window object enough to know offhand or care if it you know, like, why is this yellow and why is this gray? Like, I'm pretty sure it's like a public versus private API type thing, and yeah, I just don't know offhand. And like, I don't see IPC anywhere here. If we go to, does this have listeners? We could see the listeners somewhere, right? Shared storage, cache. Event listeners? Okay. I'm not sure where it's attaching these listers offhand either. Yeah, I'm not sure. Double check my messages here real quick. I don't see anything. So we have, I think we've dug in a bit, at least enough to understand the communication through JavaScript invoke into the listeners, like on the back end within Rust. And we're using, effectively we end up using serialization through Saturday and post message to do that communication. So how can we work with that from here? I think there's a couple things that I want to potentially look at real quick. I know at one point the reason to use post message is even if you look at the MDM docs, the post message okay. So window.postMessage fires off a message, and you can listen to messages on that window. The post message is a method to safely enable cross-origin communication. So like it's built into the sandbox that is the web view, which is why that's a useful choice. Doesn't necessarily mean that we have to use that as a choice though, because we do have to do that serialization, and I don't know that there's a better way to handle it, because we're converting from like JavaScript type values into Rust data types. The other thing that has been explored is I think we've looked at WebSockets before. I don't know if that ended up landing anywhere. Yeah. Okay, so it's in the plugin repo now. Let's look at the root to readme here. There is so use a localhost server in production apps. So if you run this plugin, you get a localhost where you can have your assets, like served from a server, instead of using this like custom protocol IPC way of passing things between. And what does that give you? You get okay, so it's serving localhost to a specific port, and then when and here what it's doing is it's changing the config that rewrite the config so the IPC is enabled on this URL. So when we communicate, or we do a post message from the front end to the Rust side of things, if this port is used as part of that like URL when you call that post message, it will hit the localhost server instead of like this Rust backend. So like I think you can run both of these at the same time. You have a localhost server where you could have some assets, or you could have commands, and you could call potentially either one of those. But this is specifically like localhost built into Tauri. So like, what's their example here? Title, build. Window builder. So first you need to do this, and then that's it. So it gets a port, window URL, external URL, config. I mean, I expect there's some level of like this being a contrived example. Tauri plugin localhost builder new port build. And so like this is, you get security risks because you're effectively exposing a localhost available endpoint like when at the user level. So like the use case for it is, yeah, you should only use this if you know what you're doing. I guess I can't think of like a great use case that you'd use this specifically, because this is adjusting the IPC layer to instead like expose the localhost. So rather than using the custom protocol and these like listeners via post message, you now have an actual like endpoint that you can hit. But yeah, I guess I can't think of a good reason to do this. I mean, we've got it as a plugin, so there's definitely like, there's got to be a use case for it, but it's not coming to me. We're gonna get to WebSocket though. We'll get there. Let's see, persist runtime scope changes on the file system. Okay. Single instance, all right. WebSocket and Windows state. Alternative language binaries. You build an Electron app that used a Haskell binary for streaming. So if you're trying to include a separate binary, you would use the sidecar or the embedding external binaries. That doesn't replace or modify the IPC layer though. All this would be doing would be bundling that external binary. So like in your case, Electron app and Haskell binary. If you would pull a Haskell binary into Tauri, you'd specify it using this to include it as part of that bundle. And then you can start it up within your like main function. Yeah, so like here, you can call the binary and start it. And Rust, yeah, child. Yeah, so like once you've got the window emit, like once you've got it running, you have like access to that child like as a separate process that's running. And you can do message passing and whatnot through there, which would, I think, effectively be the same as if, you know, a little bit more manual, but like similar in thought to what the IPC layer is doing. So I don't think you would use the localhost plugin for that situation. I mean, if you wanted maybe it's something in your binary that you just want to like provide access to on the local file system. I don't know. But the main reason we came here before I got distracted, the plugin WebSocket. So as an alternative or potentially in addition to the IPC layer, we can communicate over WebSockets. So what this is doing is we've got a init, which we might want to look at. And that on the front end, we set up the WebSocket connection. Why is it example.com? So this is all generic install. This feels weird. I thought that there was some expectation that the reason you would use this would be to communicate front end to back end. Yeah, okay. This seems more what I expected. Localhost connect over 8080. 8080 is now your WebSocket endpoint that is, so your app can connect to this WebSocket that your backend is serving effectively. And I think this has the same caveats of now you're running a local host and theoretically anything can hit it. So there are security implications that you need to then consider if you opt for this. Start server. So this is the WebSocket example. It is doing start server plugin. Okay, so this is actually starting a specific server. Tauri plugin WebSocket and net. I had in my head that the WebSocket, and this is kind of why I wanted to look at it. I had it in my head that the plugin, this WebSocket plugin, was the thing actually serving and starting up the WebSocket. They have a whole separate start server script here, which is run via the async runtime, spawn. So does this init then hook into it? Guest.js. Connect. Here's invoke. Okay, so we've got some plugins. We talked about invoke. This is where you start seeing the why we dug into seeing how invoke is handled and what it does. All of this is calling invoke for the most part. This is a slightly different situation, but so if we look at the Rust side of things, what is this actually doing then? Connect. So it's spawning. So we get a window manager. And there's web read messages on the window. So on that window, we're reading messages and we are listening for WebSocket messages. So init is setting up. If I'm reading this right, it feels to me like what this is doing is we've got a Tauri command that is send, which on the front end, when you set up this WebSocket plugin and you call send, you're sending an IPC message, which is hitting the Rust backend, and that forwards it onto the actual WebSocket server in this case. So if we look at the Svelte app example, this is doing, we've got our WebSocket. We are connecting to that separate WebSocket server that we've started. On mount, update, send, disconnect. So we have a WS send. WS is the actual WebSocket connection. But we're using this WebSocket function that's exported from this. Right? Because this is all part of it, right? Tauri plugin WebSocket API, yeah. And it is, let's double check the files. This JS, okay. And rollup is handling. Okay. So when you pull in that package, it's pulling in this file, and this file, that WebSocket that we're pulling in, it's calling this connect. So the connect fires off the invoke, which wires it up to this WebSocket. Why do we need this? Okay. String object array. We're still calling it invoke. So when you set up this WebSocket connection, rather than using the like browser implementation of WebSocket, we're actually calling an evoke instead, which instead of the, so it's still hitting the backend. The backend is receiving a WebSocket message. And it's parsing the WebSocket message, and then I think in this example, it's firing it off to this separate WebSocket service, which is interesting. So do you need a separate WebSocket service to be able to use this? I guess so. Like this, I don't think would be a drop-in replacement for just the IPC message, post message setup. It's using a bunch of that functionality. We got this invoke here, but it's not. I think you would actually have to have this separate. Like you need this separate server running. And within this, so you're effectively standing up a WebSocket server that anything else on the computer could potentially hit as well, I believe. That might be something that we play around with. I have been interested in trying this out. I just haven't gotten around to it, so that might be something we want to play around with too. And we might poke around a little bit with the docs on this one, because I think there's some unique things here that might be worth digging into. And there's not much as far as the docs go to explain what's going on here. So I think you still need a separate WebSocket service. Isn't the Rust a client WebSocket client? Isn't client? I think. Yeah, I think the answer to that is yes. I think what you're saying is you're not actually setting up a WebSocket client in the web view. You're using invoke, sending off a message, and the actual like client connection is more on the Rust backend side of things. So it's more of the like Rust backend communicating with a WebSocket server, and then passing that, like acting as like a middleman almost. I think that's, if I'm understanding it correctly, I think that's what's happening. So in which case this example, which isn't necessarily in, like, I can see this as a use case, but it is a little bit of contrived. There's a little bit of contriving. This doesn't have to be bundled. But for convenience in the example of this, that's at least some of the reason that it was put in here is for convenience. So we're starting up this separate server. You could potentially have this running in the cloud, and that WebSocket connection is going through the Rust backend into the front end then. So the question would be, what's the benefit? Because theoretically, like you could set up a WebSocket listener on the front end to listen directly to a WebSocket backend. I don't see any reason you couldn't do that. In which case, I don't know. Maybe I'm wrong about that. I don't think so though. So, presuming you can have a WebSocket connection directly to backend in the cloud, so WebView directly to the cloud. What then ends up being the benefit of using this? I think as a if you didn't have to start this separate service, WebSocket service, and you could just make the connection directly, and the backend was sort of like processing these WebSocket connections, and you could communicate over like the WebSocket protocol as opposed to the post message. CORS and CSP is why. Lower the burden in dealing with CORS. That makes sense. Okay. So this then ends up being potentially less about. So what I had in my head when Jonas was first talking about this, I was thinking it was more intended as an alternative to using the IPC layer because of that serialization. But that's less the case than I think what I was expecting to see. So we might put a pin in this. I kind of want to come back to this. But this isn't necessarily like something that you might use to try to replace like the IPC communication. Okay. So I think what time we rolling on? Yeah, let me just make sure nobody's asking for my attention here. I think we're gonna get finishing up here pretty soon. Okay. One thing that I want to touch on, Chris and I were kind of nerd sniping each other last night, and I was up till quite late. we're totally digging in. The thing that we were exploring, and I kind of just want to put the seed out there. I don't know how much we're going to actually get into it. Let's put some music on here. Yeah, that's why you woke up late. Yeah, I mean, gosh, I'm running at very little sleep. We'll put it that way. At least much less than I should. I need to function. So Leptos. Chris has been big into Leptos. I know we've poked a little bit on stream here. Leptos is a Rust framework that allows you to write code which then compiles into WASM that runs like within a web browser. There's also a component of it that expects to be run within the context of a server. So you could, let's see if I get all the crates here right off the top of my head. Leptos plus trunk is the front end. Leptos plus Axum would allow you to write backend server-side rendering, and like functions. So you could write functions in Rust that then, with a Leptos action, get executed on the backend server. In general, when you're playing around with Tauri, the default answer for what works with Tauri is a client hydrated app. So when I say client hydrated app, it's something that gets bundled and can be theoretically like all inlined into single index.html, and doesn't expect a server to also be running. So any of these frameworks that are built around the expectation of like server-side rendering, always like writing your code in a way that you have mixing of client and server code, or all the rendering is expected to happen like when you visit the page. Those frameworks tend not to work with Tauri, or potentially make less sense to get working with Tauri. So like Remix, when that came out, that was a common question, and Remix. So you don't comment on his videos. So Remix, using Remix isn't, I don't think it's impossible to do, but it's one of those frameworks where it begs the question of why. And I think there's potential use cases where, like, I think the one that Chris and I were discussing yesterday was, if you have a Remix web app and you are using Remix in multiple other places, if you then also want to support the desktop app situation, there could be value in using that same code within the context of the desktop app as well. But how do you end up working with this constraint of, ideally we don't want to be running a local host because that potentially opens you up to security vulnerabilities. The ideal being that if you don't have something running or accessible locally, there's more like inherent security. So that being said, Leptos doesn't necessarily require a server or backend. So there's some level of, let's go over and look at Leptos real quick here. And we'll see, do I still have some of these? I think I still have some of these links up. Hopefully I didn't close them all. I might have actually closed them all. Leptos. So Leptos has the you can bundle the whole front end, or you can do the server-side rendering, and then there's also these functions. So I don't know that there would be very similar to like our Remix example. I don't know that there's a specific reason to use the server-side rendering part of Leptos. That would be, I'm not gonna say don't do it, but I think there's a stronger use case to have the built, throw it up as a WASM part of Leptos and bundle that with Tauri. But the piece that we were thinking would be really interesting is still having those actions in Leptos to execute a function on the backend. And now in this case, our function on the backend isn't executing something on a server through Axum or something. It would actually be like triggering a command. And this is where this invoke function that we've been looking at this whole stream starts to come into play here. Because what we could do, this function, we just need to have a way to actually like trigger that function. So instead of hitting an endpoint and that endpoint being routed via a server to execute this function, we can use this in invoke API and a little bit of wiring within Leptos to, and this command thing within Tauri to actually execute the function instead. So let's see if I can pull some of this stuff back up. Is that like, again, we were discussing this like late at night, so Leptos Leptos dropping the CX context was a great update. That was in the recent update, right? I honestly I pretty much get all of my Leptos news from Chris. The server function. I think this is the one that we want to look at. Chris has got a 0.5. Yeah, Chris has got a video that ended up doing really well, where he rewrote pretty much everything in Rust, and the Rust Adventure rustadventure.dev site was that last piece that was hanging out there that wasn't in Rust, and Leptos was the option that won out to handle that website. And long story short, check out the video. Basically goes over all of the like why and how, and starts to get into the Leptos replacement stuff, if I remember right. But no, I mean that was you made that a handful of weeks ago, right? Time is a thing. Okay, so the we're definitely starting to get at time here because I'm getting some messages that I'm gonna have to answer here. So let's see. Oh, I scrolled right past it here. I'm sitting here talking. I scrolled right past it. No, I didn't. Is it this one? Keeps hiding my chat window here. Yeah, a couple of months ago. Okay. So I think this was sort of the piece that we zoned in on, was this handle server function inner. There's a like a macro that generates the server part of it. So instead of us needing to generate like routes that are then handled, that take up the mantle of handling these function calls, like if we check through here, we got server function call, protocols, refers. So like all of this bit is we are handling the response, and then okay, here's the could not find a server function. Server function create is also relevant. Is that in Leptos? So instead of, there's definitely there would require some not insignificant lines of code to make this wiring happen. But what this is doing is just generating the routes to handle these and like to route to these server functions. So in a similar fashion, in Leptos repo, okay. In a similar fashion, we would need to do a small Leptos integration that instead of generating routes for Axum, for example, which would trigger or allow one to route to and then trigger these functions, instead we would wire it up with this invoke API. So the invoke call, or the action on the front end with Leptos, would instead fire off an invoke call, which would then be wired up to a command that executes one of the functions. And I think you could do some of this manually. Like you can, I guess effectively, if you were using commands within Tauri, you were doing it manually. So if you're writing Leptos code to call on an invoke in the Tauri app, that would be the manual method. But what we're thinking here is if you could write your function next to your code, your Leptos code to do the front end, and it handles all of the wiring up of the Leptos action to the invoke call to the backend command to eventually fire off this Leptos function. That would be really nifty. And that was, I mean, that at the gist of it was the nerd stipe that happened between the two of us here. And is it in this? Okay, server macro impl words. Should I say didn't get much sleep here? I don't know that there's anything specific. I was looking all on the Tauri side of things, and Chris was all into Leptos. So Leptos is definitely more of a Chris's domain than mine. Yeah, I think that was we started hitting these. We had some like advanced use cases of these. Gosh, why can I never remember what these are called? Config metadata thing. I don't remember. I can never think of a good way to like Google for that either. But it's just not sticking in my brain. Either way, we had a bunch of the advanced ones that were like, what is this doing? And then we just said, okay, we need to go to bed. So we've got wasm, get server URL. I feel like I came here for a reason, and I'm not remembering what that reason was now. Payload. Yeah, so this can be used by a server to handle the requests. So this is an ActX web example, and it's wiring up to accept these responses. So this is like the wiring of, I believe, Leptos action to the server to actually fire off the function call. See, it runs the function on the server. Server function trait is in that file. So if we look for, well, this can we do, can it be under trait server function? Here. Yeah, actually that's what I was just looking at. Perfect. Yeah, so this ends up being like the piece that actually ends up executing that function on the server. So there's just to get an idea of what these actions look like. I don't know what they look like offhand. We've got signal, clear, increment, decrement, and then this is the thing that it gets the rendering macro. So what does an action look like? Like, what's the interface on the user side of things? So like the idea then would basically be you would write your view code, you'd write an action in the same spot, and this little integration would handle the wiring up of the invoke call to the backend in the command macro part of it in Tauri. So like if we look at so like this in the Rust side of code, you write a command, which is also a macro that generates a bunch of code, which handles the listening for that message and then firing off this specific function. But if we're writing the function next to our Leptos code, it would be nice not to have to like co-locating these would be handy. And if we don't have to handle all of that wiring, you can have your view and then your action right next to each other. It would be kind of nifty. So what's that action look like? I think maybe we check out an example of an action because I don't know what that looks like offhand. And that might be a good place to call it. Cargo Leptos. Examples? Or API documentation. Maybe that'll be a better place to go. Server functions, create action. Okay. So you call create action and then, I mean, this is kind of a contrived example. Do they have a good example that we could use? Counter, error boundary, fetch. Don't see anything that specifically says action. So we might just have to guess on which one might be interesting to look at. I'm guessing counter is the like signal type stuff. Simple counter, create signal, yep. I guess the call is create action. So if we search for, I don't think it's gonna let us do it here. Create action. So you have to be signed in now, I think. Yeah. Alright. I think I'm gonna have to end up signing in or something and just being careful on what I share. Create action. So we want to search within examples. Counter isomorphic. Okay. So there is. Did I close my examples folder? I might have. Counter isomorphic appears to have some calls. So if we look at main, server only stuff, okay. Client only, main for trunk, okay. So the SSR is setting up a stream, event stream. And the route has an API, so we have handle server functions. So then guessing our counter is just gonna have our view code here. Yeah, so we've got our view. Form counter, where's the root? I think it's counters. Each of these counters stores the same variable on the server, okay? So we have counter, form counter, multi-user counter. And function counters, okay. Then there's the component counter. Now we've got create actions. Okay. So it feels very much like this feels kind of like hooks in React. Here's a server function. Can I copy? Can I paste very well? Fine, we'll find out, I guess. Yeah, so on the server side, you would do this is setting up the function to be triggered when you hit this like endpoint. So when somebody hits this endpoint, you would do this work and then return the to-dos. So this would be the bit that we would effectively want wired up with the command instead. Doesn't necessarily like have to return data. Like the use case is potentially slightly different. It might be firing off like, you're in a Tauri command, so you could theoretically do anything on the Rust side of things. Like you could click a button to shut down your computer, I guess even. I think you could do that. But in general, like the server functions are probably more, the expectation is more that you're doing some work and then returning data, which we could also do. So like you could hit that server function, execute, you could do some heavy lifting in the like Rust backend side of things and then return the data or something. And this would then end up, I think, being in the command, and then we have the like WASM side of things where we're doing create action, and this plus this would be the code that you need to write, and it would be the things that would be generated would be the wiring, taking this create action, generating the like invoke, and then the wiring it up to the command API on the Tauri side of things. I think it would be interesting. So yeah, it definitely nerd sniped Chris and I. We were digging into it a whole bunch yesterday. So if anybody else is interested, feel free to like leave a comment below or something, and maybe if there's enough interest, things could get rolling. It seems cool though. All right, I think that's about it. I need to get running here. Is there anything else? We do want to look at that WebSocket plugin. That might actually be a good next stream. I think we'll be here next week. It is a holiday week for folks in the US. So, but I expect that I'll be able to stream on Tuesday. So we might actually look at the WebSocket plugin. That might be fun to do, but we'll see. For the most part though, IPC is going to be the layer that you're communicating over, and there are reasons to potentially use a different protocol, but then there's trade-offs with that too. The value of using this post message IPC protocol is the fact that there's a lot of like built-in sandboxing and whatnot that happens in the web view side of things, which as opposed to using like shared memory, brings improved security with it. So we'll look at that WebSocket one, I think, next time. That might be what we do. Anyways, I need to get going. Thanks for stopping by, everybody. It was a good stream. I enjoyed digging into this, and I knew I had a high level idea of how this all fit together, but it was nice to see the actual code and wiring it up, and seeing how it all wired up together. And I am interested to like experiment a bit with like how things are communicating, especially once we start to get Rye as something that we can embed in like the context of a Bevy app or such, and having that communication between the two. State management definitely becomes more complex in that situation, and Rye plus Bevy is very much a different situation than like multi-window. But there's similar thought paths that you need to go down when you're dealing with it. So I think it'll be interesting. Anyways, enough of the rambling. See you next Tuesday. Thanks for stopping by, everybody. Appreciate y'all. Have a good one. Bye.